Dear students, just you remember कि in the first PPT of the Fourier series we discuss about कि what is the Dirichlet condition and what is the Fourier expression, how we can how you can write the Fourier expansion of any given problem. And now today you know कि as per the definition of Fourier series कि Fourier series is nothing but the combination of sine and cosine series. So today we will discuss something more in Fourier series. So in this connection, the first of all is कि what is the sine and cosine series. So for even fx we know कि what is the sine this Fourier series. Fx for the even function that may be expressed into the form a naught by 2 plus summation over n is equal to 1 to infinity a n cosine n pi over p into x. So you can look this even function and the graph of even function. This is very clearly here. If y is equal to x square, that is an even function. Then what is f of x and f of minus x? You can see here very clearly. And then in this case, in the when the function is even, then a naught may be defined as 2 over p 0 to p fx dx, and an may be defined over as 2 over p 0 to p fx cosine of n pi by p x dx. Similarly, in case of odd function, also we can define this as this series, that is sine series, and which is the odd function. You can look here, qi is equal to x cube. It means here the function is odd, and in this case we get only bn by using the definite integral properties. So bn is equal to 2 over p 0 to p fx sine n pi over p into x dx. So this is about the sine and cosine series. If you go in detail, when we deal with the Fourier series of fx in symmetric interval like minus pi to pi or minus a to a, then it is advantageous to test the even or odd nature of the function fx. Because of that, the previous PPT we have seen what is the sine and cosine series when the function is even and odd. As such function have the important properties, as we discuss in the case how by using the definite integral property we can eliminate quickly the Fourier coefficients. So minus a to a fx dx is 0 if fx is odd, and 2 times 0 to a fx dx if fx is even. So this is the well-known property. If fx is an odd, then the Fourier coefficients a naught will be 0 and an will also be 0. So we have seen in the second case, that is you will get only the bn. Bn is 2 over pi 0 to pi fx sin nx dx. So Fourier series fx is equal to, in this case, that is n is equal to 1 to infinity bn sin nx. Third case is very obvious. If fx is an even, then the Fourier coefficient bn will be 0. And in this case, fx is equal to a naught by 2 plus summation over n is equal to 1 to infinity an cosine nx. So that should be very much clear when the function is even, when the function is odd, then how you can define the different Fourier series with the different Fourier coefficients. And just for the computational process, as I discussed in the first PPT also, you should revise the previous 10th and plus 2 level mathematical formula, like what is the value of twice sine a cos b, twice cos a cos b, twice sine a sine b, and twice cos a sine b. Okay, and in addition to that, you must remember these values. This is very much useful in discussion of sine Fourier series. Sine n pi is 0, sine 2n pi is 0. It means sine 2n plus 1 pi by 2 is minus 1 power n, you can write, and this will depend upon the n. If n is odd, then value is minus negative, and if n is even, then value is positive. Similarly, cosine n pi is also minus 1 power n, and it will be plus minus 1 if n is even and odd respectively. But cosine n plus 1 pi is minus 1 power n plus 1. Okay, cosine n minus 1 pi is minus 1 power n minus 1. Cosine 2n plus 1 pi by 2 is 0. So these values, if you remember and you keep in your mind, then that will you can save the time, and that will be very useful for the numerical problems. Now let us look one example. we have to obtain the Fourier series for fx is equal to x square if x is lying between minus pi to pi. And if you establish the Fourier series, then you have to also to prove that 1 over 1 square plus 1 by 2 square plus 1 by 3 square and so on is pi square by 6, and 1 by 1 square minus 1 by 2 square plus 1 by 3 square and so on is equal to pi square by 12, and last is 1 by 1 square plus 1 by 3 square plus 1 by 5 square and so on is pi square by 8. So now given that fx is equal to x square, it is given where x is lying between minus pi to pi, it means the Fourier series of fx is equal to ये क्या है, that is the even function. It means the Fourier series you can write if fx is even, then bn will be 0, and series is a Fourier cosine series, and that is fx is equal to a naught by 2 plus summation over n is equal to 1 to infinity an cosine nx. In this case, just you calculate what is the an, and if you calculate the an, then you will get that is twice pi square by 3, but you check at your own level. Now after getting an, a naught, you will go for an, and an you can find out 2 over pi 0 to pi fx cosine of nx, and in this way you can evaluate the value by integration by part, okay, and by integrating by part, just you complete it, then you will get 4 by n square minus 1 power n. It means you got a naught and an, and so you can define here the cosine series that may be written as x square is nothing but this is equal to pi square by 3 plus summation over n is equal to 1 to infinity 4 by n square into minus 1 power n. Now different values of n you can put here, and you can get the different, because you know Fourier series means this into cosine nx. Here you must mention this is cosine nx also here. Here this is cosine nx also. You can write here cosine nx. So if this is cosine nx here, you can mention here this is cosine nx. Okay. So now if this is cosine nx, then by putting the different values of n, here you will get 4 times minus cosine x by 1 square. Once again I will repeat, here it is left here. You can write cosine nx. Then after putting different values of n, you will get this series. Now if you put x is equal to pi, then you will get this result. Let us suppose this is equation number 1. Then after putting x is equal to 0, you will get this result, and in this way, by combining both the equation, you can prove that 1 by 1 square plus 1 by 3 square plus 1 by 5 square is equal to pi square by 8. In this way, after putting the different values of x, you can establish all these three forms. Thank you very much. Thank you.